Okay, today we're going to be having a look at rates of reaction. The two items that we've got to measure is we've got magnesium ribbon, strips of magnesium ribbon. Here the one is showing me that that's cut to 1 centimetre. They've been quite accurately cut. We're going to pop the length of magnesium ribbon into a test tube. The test tubes will have hydrochloric acid, 1 molar hydrochloric acid. The 1 molar just tells you the concentration of that solution. Yes, we're going to see how long it takes for the magnesium to disappear in a reaction with the hydrochloric acid. So we're going to time that on the timer. The hydrochloric acid that we used throughout the experiment is the same bottle to make sure it's the same concentration of solution. What we're going to do, we're doing 1 centimetre, or rather 10 millimetre length at the moment. I've already done a results table of 5 millimetre, 15 millimetre and 20 millimetre lengths of magnesium. We're doing 3 at a time just so that we can get an average which gives us a more even score. If we only do 1, we might have had a particularly fat or a particularly thin piece of magnesium ribbon that might give us a misleading figure. So we're trying to do 3 to average it out and make it a fairer way of doing it. So I'm just going to measure. This is actually a glass measuring cylinder. I've only done it in this because it's actually easier to use than the plastic ones that you'll probably be more familiar with. So we measure out 10 cubic centimetres in there, or 10 millilitres. That goes into there. Nice and carefully. So we know we've got exactly the same quantity in each of those. And literally all I'm going to do is pop that in and start the timer. Pop one in the next one and start the timer. Pop one in the next one and start the timer. So there we go. To the next one. And the next one. Now obviously what I'm going to do is stop the timer as soon as I can see that there's no longer any reaction going on, and I will know that because the magnesium ribbon actually effectively looks like it's disappeared. You won't be able to see any magnesium ribbon in there. I'd just like to point out, as you can see with the camera, you can see it's fizzing, so there's clearly quite a strong reaction going on. The fizz is producing it almost looks like a smoke, doesn't it? So we can see that actually some gas is coming off there. And if I just ask Mr. Mead just to pop his thumb over the top of there, we're going to do a simple test that might tell us what that gas is. Okay. That is called the pop test. And when a gas pops under a lit flame, it's indicating the presence of a particular type of gas, which you might want to have a little look at to understand what gas that is. Something for you to find out for yourselves. So literally I would run that now for probably another 20 or 30 seconds or so until we can no longer see any magnesium. Can you just see in there, Mr. Mead, that they're getting smaller and smaller each time? The ribbon, by the way, to make sure it's as fair as possible, has been cut off the same length of ribbon. We haven't used different items of ribbon. It's just another way of trying to make sure that our results are as accurate as possible. So as soon as that no longer is reacting, I would stop the clock. Those times we've already recorded. You can see here I've recorded the length of the magnesium, 5 millimetre, 10 millimetre, 15 millimetre and 20 millimetre. I've done sample 1, 2 and 3, the white, the red and the blue. On each different one we've done exactly the same experiment several times over. These are the times in minutes. We obviously need to convert that into seconds, and then I've worked out the average time in seconds for the reaction to be complete in the 5 millimetre. So this explains for each of them. The only average that I haven't calculated, but I'm sure you will all know how to calculate, we need to add 151 to 156 and add that to 161 and then divide it by 3. We've got 3 samples, so we add all of those up and divide by 3 to give us the average time in seconds. But that essentially is what we need to do. Your teachers may well get you to produce a graph or something similar, and you need to think about how you might label up your graph. But we've essentially just had the one variable in the whole experiment should be the length of the magnesium ribbon. You can see, just to show you, obviously because I was talking I didn't stop the clocks, but you can see now that the reactions have stopped, there's no more gas being given off, and you actually can't see. So we've gone over the time effectively, and that's why I'm going to disregard those as a set of results. But I hope that's explained everything okay to you, and I hope it's useful. Thank you.